I think in the last couple of days already thermoset and thermoset plastic and mathematical modeling and simulations covered, and basic understanding about the composite I think covered, right? Then before going to start in detail about the thermoplastic composite materials, you have an idea about the reinforcement materials as well as a matrix. So reinforcement materials generally fibers in the form of fibers and yarn, and then we need to convert in the different structural form, that may be the UD and woven fabrics and different 3D structures preform as well. So any idea about the fibers and yarn, because there are different type of reinforcement materials, natural materials and the synthetics or man-made materials. In case of the natural materials, like you can say jute, flax. Nowadays from the synthetic fibers to the people are shifting from the natural fibers reinforced composites. So now I will start with the different type of composite and the basic classification. Maybe this is the repetitions. So the basic classification is ceramic matrix composites, polymer matrix composite and metal matrix composites. I will start part. So today we will focus on the thermoplastic composites, because in the last lectures thermosets, in case of the thermosets, reinforcement material may be the thermoset in case of the thermoplastic materials. For example, aramid fibers or a carbon fibers, their nature is thermoset. It is not a thermoplastic in nature, like PBO, Gylon and glass fibers. Their nature, glass fiber is in the category of thermoplastic, but aramid is a thermoset in nature. Then how we are saying it is the thermoplastic fibers, the thermoplastic composites. That is basically we are classify according to the matrix. So which matrix we are using? That is matrix, if we are using a polyester or epoxy base, then that is comes under the category of thermoset matrix. Then there are different metal matrix composite that is also used in the automobile industries, and this is the basic schematic view of the composites. Basically there is the fibers. Sometimes we are using the terminology fibers and the filament. The difference between the fibers and the filament is a continuous entity, and sometimes I will also use a yarn, filament yarn. So that means in that yarn there is a that is the composed of multi filaments, right? Sometimes I will use the terminology fabric. That means there is the interlacement of the yarns in the different structural forms. And then I will also use the terminology UD cross ply laminates, UD laminates. That means the orientations of the yarn in the one direction, that is comes under the UD laminates. So why we are talking nowadays thermoplastic composites? Because initially thermoset composites widely popular, and the main concern with the thermoset composite is that is not environment friendly and sustainable in nature, because matrix after the 10, 15 or 20 years you can't recover again, you can't reprocess that materials so that you can use for the in the another form. So in case of the advantage of the thermoplastic material is that you can get the resin or maybe reinforcement material again, and you can convert it into the valuable products. That is the benefit. So it is the benefit for the to protect our environment as well. So these are the problem statement related to the thermoset composite as well as the thermoplastic composite. These are the listed merits and the demerits. The merits of the thermoset composite is the thermoset composites are a good abrasion resistance and low viscosity in nature. So easily you can prepare the composites. So handling during the thermoset resin, you will not get too much difficulty, but in case of the thermoplastic composites, you need to the main concern with the viscosity, higher viscosity. So viscosity is the major problem. To overcome this problem, we can prepare the different preforms by using a different techniques. Maybe some of the techniques already covered, and maybe some of techniques are new for you. And the merits of the thermoplastics, you can see the merits is more in case of the thermoplastic composite as compared to the thermoset composites. And demerits is the higher viscosity, and solvent is also required to dissolve the thermoplastic composite, and the polymer degradation, because thermoplastic composites are temperature sensitive materials, and so we need to take care about the processing temperature and everything. These are the different manufacturing techniques which we will cover one by one, the compression molding, injection molding, and extrusion and pultrusion. I think the manufacturing techniques for the thermoset matrix already you have gone through: the pultrusion, resin transfer molding, hand lab techniques, and filament winding. These things as per your syllabus, this is covered. And then thermoplastic composites, that is the injection molding and diaphragm forming. The diaphragm forming is nothing, is the similar kind of, you can say, the pressure in the hydrostatic pressure form you can manufacture the composites. And then film stacking method as well as a powder coating method, stapling methods, these are the different thermoplastic composite manufacturing techniques. So compression molding basically is a very oldest method techniques. In this case there is nothing, we can heat the platens as per the resin, because suppose that you resin in the resin polyethylene, then in that case you keep the temperature around the melting point. For example, as in case of SDP, the melting temperature is 120 to 122 degrees Celsius, you keep that temperature, and under the pressures, basically from the pressure you can get the mold, whatever you want a shape, that shape you can get from this compression molding. Generally the compression molding can be is used for the medium to the large part. It can be used for the hard armor applications. Hard armor can be prepared from this compression molding techniques, which is used for the protective armors, bulletproof jacket. Then injection molding, generally you can, I am giving the very basic example, toys. The component of the toys that can be manufactured from the injection molding. In that case, we need to feed the pellets of the polymers, and then from the extruder. And after the extruder, and the purpose of the extruder is to melt that polymers. And from after melting, we can convert it in the required shape, and by using an appropriate die. Whatever you want to produce a shape, you can convert it from the injection molding. Generally this is used for the mass production of small and complex small segment of automobile sectors, as well as toys, and some gears you can also manufacture from the injection moldings. Then extrusion techniques. From the extrusion techniques you can extrude the pipes like PVC pipes, or any thermoplastic matrix based pipes, and seats, LDPE seats, that is also a preform. These techniques can be also manufacturing in the preforms of the thermoplastic composite, as well as some structural part you can also prepare from these techniques. Then this is the another technique, pultrusion techniques. In that case, you can from this creel you can get a filament, and after that from this die you can impart a thermoplastic resin, and then you can prepare the thermoplastic composites. This is the pultrusion techniques, and the application is the beam, rods, and other structures profiles can be manufactured from the pultrusion techniques. This is the comparison chart between these different processing methods: compression molding, injection molding, and extrusion and pultrusion. The advantage of the compression molding, it can be used for the small part to the larger parts, as well as a low tooling cost, and disadvantage is longer cycle of the time. Basically when you need to heat and then cool down, so the cycle time is more. in case of the compression molding whenever you are preparing. So in that case you need to enlarge the platen size. Whenever you are going to enlarge the platen size, then the control and the alignment of the platen, that is very important. So generally this compression molding also used in the rubber industry as well. Then injection molding. Injection molding is the production rate is high and precise and limited for the small parts. Then extrusion methods, that is the continuous methods and limited for the simple profiles. Like I have said that I told in the previous slide, it can be useful for the pipe manufacturing or seeds, these kind of things manufactured from the extruded methods. Then pultrusion, that is the high strength and continuous methods. High strength materials can be manufactured from the pultrusion. Basically you can for example, you can use a carbon fibers or glass fibers as a reinforced materials, and then you can apply the resins. These are the different tau prefect manufacturing techniques. So basically, whenever you are manufacturing the composite materials, you need to prepare the tau, and the tau can be prepared by the different techniques. One is the commingling process. From the commingling process, you can see there are two materials. One is the reinforcement filament, another is the matrix filament. Basically, I am giving the very simple example. You want to make the aramid and polypropylene composites. Aramid and polypropylene composite. So aramid fibers basically used for the strength and modulus, high modulus and high strength. And the polypropylene, that will act as a resin material. Basically that will enhance the interface between, that will bind all aramid fibers, or you can say preforms together, and then you can make the composites. So in that case, matrix generally used as a low melting temperature, but whenever you are choosing the matrix, that is very important. The matrix should the processing temperature of the matrix, that should be lower than the degradation temperature of the reinforcement filament. For example, para-aramid stable up to 350 degrees or 350 degrees Celsius in the normal atmosphere. Whenever you are going for the inert atmosphere, it is stable up to the 400 or 450 degrees Celsius. In that case, polypropylene melting temperature is around 160-170 degrees Celsius. So you can prepare, you can manufacture this aramid fiber reinforced composite. Then reinforcement material, then matrix. Then you need to mingle at the level of filament, and then you will convert it the preforms in the woven fabrics or any kind of structures you can convert. Like first you need to mingle the matrix at the filament level, and then that means why you are doing these things, because I told in the initial, the viscosity, the higher viscosity is the problem in case of the thermoplastic materials. So to overcome that viscosity distance, because whenever the higher viscosity, then polymer will not able to flow during the composite formation. So we are mixing the matrix at the filament level, and whenever you are going for the mixing of the matrix at the filament level, then you will get a appropriate uniform composite, void free composite. That is the target by using this commingling process. So nowadays commingling process is more popular to prepare the thermoplastic composite. Then there is another technique. This is the friction spinning process. From the friction spinning process, you can feed the continuous filament. Continuous filament here is act as a reinforcement material. That may be the aramid, that may be the jute, that may be the whatever you want. That reinforcements may be the natural fiber base or the synthetic fibers base, as per your requirement. Then matrix you are using in the spun form. Staple form. Basically staple form fibers, I think you are from the mechanical background, so sometimes you are confusing with the fibers or the filament and the sometimes yarn. So fiber staple, whenever I am using a staple fiber, that means you can assume as a cotton fibers. Cotton fiber length is short. So in this techniques, the condition is that whenever you are using any matrix, that should be in the form of staple form, yani ki short staple form. That things you can mix at the friction spinning process. From that you can make the preform, and after the preparation of the preform you can convert it as per your requirement, like woven fabric, 3D structures, whatever structures you want to prepare, you can prepare, and then you can go for the compression molding, or as per, I think in this case the most important and suitable machine is the compression molding. Then there is another technique. This is the braiding process. I think I am here giving the very simple braiding example. Even though from the braiding, these techniques you can also prepare the pipes, thermoplastic composite pipes from these techniques. And there are different type of braiding technology. So this is the only Maypole lens braiding system I am giving. But principle wise, all techniques are same. Then these are the tau prepared provide the different type of solution. For example, the resin and matrix is the side by side laying. So that means melt flow distance. Melt flow distance, what is the meaning of melt flow distance? Basically, during the composite formation, resin will melt, right? So resin will melt and the matrix, reinforced will not melt, matrix will melt. That is the resin basically. Matrix will melt and then it will go toward the inside the reinforcement materials. In that case, if you are manufacturing a side by side preform, in the melt flow distance is higher. But whenever you are shifting to the commingling process, that means the reinforcement materials and the matrix is mingles in case of the reinforcement materials, and whenever you will make the composite from this materials, so easily it will adhere the all reinforcement materials. It will all reinforcement materials or filament will stick together. So that's why I told co-mingled is the most important techniques. So from this example you can see this is the fibers. Fibers here is the reinforcement materials, this one is the matrix, and that is used to adhere the reinforcement materials. And in the co-mingling process, whenever you will see the cross section of the yarn, the distribution of the matrix and reinforcements is like that, then you can see the melt flow distance is lower in this case, and you will get a more uniform and having a lesser delamination problem from these techniques. So these are the different techniques. One is the commingling, frictions, even though in ring frame you can also manufacture in the plying process like TFO process, from that you can also manufacture the preforms. This is the commingling process which I have discussed earlier, and the problem how this commingling process overcome the problem of the melt flow distance, those things I have also discussed. Now I am coming to the characterization part. Whenever you are making the preforms, then you need to confirm कि really it is happening or not, whatever your thought process. So then you will definitely go for the optical microscopic, either you will see the cross section wise or the longitudinal view of the filament. So from this cross section, whatever the thought process, how the matrix and the these are the different techniques. This one is the commingling yarn, this one is the friction spun tau prepack, and this one is the braided. In case of the braided, from this longitudinal view you can see this is the aramid and this is one is the polypropylene. So just like is the binded is the cover reinforcement by the polypropylene, but in that case the filament level is distance is more, but in case of the commingling, the matrix and reinforcement materials is mix at the filament level. Whenever the matrix mix at the filament level or reinforcement level, then you definitely whenever you will prepare the composite material, that will be more uniform, void free, and you can avoid the delamination problem. So these are the composite manufacturing process. From the compression molding, and in case of the compression molding, again you need to set the temperature, pressures, and processing cycle. That is very important because that processing cycle is, again I told, it's depend on the type of materials, which type of materials you are processing. Suppose that you are processing nylon. In that case, the processing cycle vary. In case of the PEEK, polyether ether ketone, then the processing cycle is varied. So as per the requirement, we need to optimize the process parameters. Even though in the modeling and simulations, you can consider this parameter, but as I am an experimentalist, so I would like to say ki, something you can think or you can simulate in the modeling, but whenever you go for the practical and the application point of view, sometimes we need to do some jugaad. Sometimes theory not works, right? So similarly, we need to optimize at the what level? Yeah, from the modeling and simulation, you can reduce that numbers. That may be the benefit of the modeling and simulation, like number of permutation and combinations you can reduce from the modeling and simulations. But experiment is equally important. Because in case of the modeling and simulation, whenever you go for the commingling and the representation of the commingling, that will automatically distribute whatever you want a distribution, that will distribute the filament. But practically it's not like that. Whatever you want distribution, that will not happen. Right? The mixing of the filament or reinforcement, you can say reinforcement and matrix material is not according to the theoretical calculations. That will be affect, right? And then because and today I am also covering the characterization part. So is the overview, so that whenever you basically the purpose of these things is so that you can understand how we have to plan the composite manufacturing. You can manufacture, what kind of characterization needed, and how you can evaluate that composite. That is the, I think, objective of today's lectures. Then void determinations. Definitely whenever you are making the composite, then everybody is asking what is the void percentage. So how you can calculate? The very simple, basically from the rule of mixture you can calculate the theoretical density, and then you can also calculate the experimental density, and this way you can confirm the void percent. And another, from the microscopic view, you can also calculate by area. But that I will say ki density method is also appropriate, but in this case you can skip something, because you can calculate total area, and then that is another way by which you can calculate the void. Then flexural rigidity of the composites. So this is the ASTM D7264 standard. As per standard, you need to prepare the composite, and you can calculate the flexural properties of the composite, because flexural generally people are also testing the tensile properties. But in case of, suppose that I am using a composite to manufacturing this table, so in that case generally the load is in the in the cantilever principle, not like tensile load. No? If you are talking about the impact, then you will go for the impact, because you have used the composite in case of the bonded preparation of the any automobile. Then in that case impact is an important factor. So as per the requirement, you need to plan the test. So these are the failure analysis after the destructive testing, and then you can confirm what is the happening, which kind of failure is happening. According to that, you need to tune your pre-packs, and you can also change the composition of the reinforcement and the matrix. Then ILS is interlaminar shear strength of the UD composites. So this is the well-defined standard, ASTM D5379. From that you can calculate the ILSS. ILS is nothing, is the applied load, peak load, and then width of the specimen across the notch, and then thickness of the composite of the materials. This is the ILS. Generally whenever you are going through the composite materials, this characterization is done. In case of the experimental papers, along with these parameters also helpful in the simulations as well. Now I am coming to basically I am giving the real life example, and that is also the my area, bulletproof jacket, body armor. So in case of the bulletproof jacket, thermoplastic composite is also used. The purpose of the what is the basic requirement of the bulletproof jacket? It should be lightweight and flexible in nature and cost effective, right? That is the target. First is the lightweight, and the second and third is the, I think, a least bother factor. first factor, it should be the lightweight, right? So we can go through the history of the armor from nylon flak jacket to the now aramid or ultra high molecular weight cross laminates based jacket is nowadays using. Initially the jacket weight was around 20-30 kg. Nowadays the jacket weight is 10 kg. So why it is happening? Either the changes level at the reinforcement materials or matrix materials. That is the main thing. So reinforcement material, earlier it was used as a aramid. Nowadays single polymeric composite is useful, like that means UHMWP, ultra high molecular weight polyethylene, that is the gel spun fibers, and nowadays using in case of the bullet resistance. I will say bullet resistance jacket, not the bulletproof jacket, because bulletproof, that means ki completely proof. That is not the case in case of the bullet resistance jacket. So sometimes there is a 80% chance, 85% chance ki the human can protect from that, and 5 to 10% is still, if you have followed the everything, every standard, but there is a chance the wearer may be injured. So bulletproof, whenever you are using a proof terminology, that is not the right for that. Even though in the public domain that is already reported the bulletproof, right? These are the different materials, and the interesting thing is that no materials, aramid, carbon fibers, gel spun fiber, UHMWP, we are not manufacturing in India. Any fibers, any high performance fibers, and there is the, like you can say, vast opportunity in case of the these high performance materials. Lot of calls, even though researchers can carried out their work in this area, high performance fiber, especially in Indian context. Day before yesterday, we got a mail from ISRO. There is 3 to 4 project that is also relevant to the high performance fibers, because this high performance fiber based composite is used in everywhere, in the defense, in the aerospace industry, because aramid, I am giving the example of aramid, that is temperature resistance, that is used for the fire protective clothing as well, composite as well. So it is provide the high strength, high modulus as well as a fire protection properties. So it's the specific fibers, and so it's I'm not saying proudly ki we are not able to manufacture these materials. Definitely in the 5-10 years we should manufacture this kind of materials. And another is the UHMWP, ultra high molecular weight polyethylene. One of the industry, they have working in this, and they have successfully manufactured that fiber, and I proudly say ki I was working with that industry and in my PhD work, and maybe in the within 2-3 years we will at least provide the materials for the bulletproof jacket applications. So that is the UHMWP. Basically I will also cover that materials in the subsequent slide. So these are the aramids, para aramids. You heard the aramids terminology in the last 2-3 days. But there are different aramids, para-aramid and the meta-aramid. Meta-aramid is used for generally for the fire protective clothing, and para-aramid used for the this kind of impact resistance application, because it has a higher strength and modulus. But in case of the meta-aramid, strength is lesser as compared to the para-aramid because of their chemical structures. Then ultra high molecular weight polyethylene. In worldwide there are 2 industries which is manufacturing the ultra high molecular weight polyethylene. One is the DSM Dyneema, and another is the Spectra. So these are the different materials, and this is work which I have carried out and already published in the research paper. So you can go through in the detail of these materials. And this one is the materials, I would like to say this is the indigenous materials, ultra high molecular weight polyethylene tape. or I can say disentangle polyethylene tape, because the processing method is different than the gel spinning methods, and this method is also cost effective. And from these materials we have also manufactured the this is the polymer, from polymer to the then tape, and from this tape we have manufactured the bullet resistance jacket armor panel, and we have successfully got the positive results, and soon we will go to that direction. Definitely that is my PhD work, so that industry will go. Now I am detached with that project. And so the methodology is like that. These are the filament, then laminates and fabric, then these are the armor. This is the combination of the soft as well as a hard armor. You can see this one, the back side is known as a soft armor, and this one is the hard armor. So hard armor again is the made from the thermoplastic composite. What is thermoplastic? Basically UHMWP fibers and the reinforcement materials, either rubber or polyurethane matrix, is used to manufacture the hard armor panels. Then nowadays in case of soft armor, the shear thickening fluid is also used. Then evaluations, definitely whenever you are going for the any composites or any materials, you need to evaluate as per your application requirement. And generally in case of the bulletproof jacket, BFS is measured, backface signature is measured, depth is measured in case of the armor jackets. So what is the BFS? This is the clay. I would like to say it's representing the human body. So whenever you are, so in the back side you can see this is the clay like materials, toy clay. Then you are putting the jacket on this clay, and you need to fire as per the thread level. ऐसा नहीं है कि everywhere every jacket is provided every kind of threads. Like for the pistol requirement is different, for AK-47 requirement is different, for sniper requirement is different. So according to that you need to design the jacket, you need to prepare the composites panel. So this hard armor generally used whenever you want to get the protection from the for example AK-47, and this soft armor is sufficient to get the protection against the 9mm bullet. Pistol, basically the small pistols, or you can say small arm ammunition, submachine carbines, those kind of from that weapons this soft armor will able to provide the protections. So again these are the different characterizations machines used. Suppose that you want to determine the rheology of your resin, then you will go for the rheometers. Then for the melting point or crystallization temperatures or glass transition temperature of your resin or reinforcement materials, then you will go for the thermal analysis, that is the DSC, differential scanning calorimetry. And for the thermal behavior, suppose that where your material will able to sustain in the presence of oxygen, in the presence of nitrogen, then you will go for the TGA, thermogravimetric analysis. And then XRD, generally you want to see the what kind crystallographic structures of that materials, and how this crystallographic structures changes with the temperature, with the processing temperature, how the orientation is affecting of the fibers. Definitely whenever you are processing at the higher temperature, that will affect the reinforcement material as well as the matrix materials. Then this is the characterization at the level of fabric. Whenever you are making the fabric from the preforms, then you need to see the what is the friction between the yarn to yarn during the preform fabrication. So these techniques you can use. And then tensile testing, sometimes stiffness is flexibility. For the testing of the flexibility you can go for the stiffness testing. For the impact evaluations, you can evaluate the low velocity impact. Generally this kind of testing method is used for the automobile industries. And for the backpack signature or ballistic evaluation, in that case real weapon is used, either real weapon or barrel. Barrel is nothing, is the weapon simulating projectiles. So this is the methodology by use you can, how you can manufacture, and the entire manufacturer's methodology is listed here. Then thermal analysis. So this is the case study. We have analyzed the para-aramid cross-ply laminates. Whenever you are you want to see exactly you have tested that you have manufactured the thermoplastic composite for the aramid as well as a LDP resin. Then you want to confirm the you can take the small portion of that materials, and you want to see what exactly that whatever you have decided the percentage, like 30% or 40% of the resin, that is existing, or theoretically that is not like this calculated is okay, that is uniformly distributed or not. Then you can confirm from the TGA, thermogravimetric analysis, and that in that case you can confirm how much the resin or how much the fiber reinforcement material in that particular region. From TGA those kind of things you can also confirm. And what are the other constituents? Sometimes you want to see you have added some nanoparticles during the composite manufacturing. From the TGA you can see how much the percentage uniformity of the dispersion of that materials. Those kind of things you can also confirm from the thermogravimetric analysis, because in case of TGA you will use a small portion of that composite. So a small portion you can take from the 4 to 5 places, and then you can see is the uniform or not. That is also a one confirmation test. Then from the differential scanning calorimetry, whenever you are going to plan a process parameter in case of the compressor molding, suppose that you want to perform as you want to fabricate the composite under the compressor molding, and you need to set the temperature. So blindly you can't say okay is the 130 140 degrees Celsius. First you will test your material behavior. First you will test the what will be the material behavior with respect to the temperature. So that material behavior you can test from the differential scanning calorimetry. From differential scanning calorimetry you can see the melting point, melting behavior of that materials, and from that you can choose that temperature. Otherwise you can also reduce the number of that cycles, like optimization cycles, if you have a basic characterization knowledge. Then failure analysis. I am giving the example of failure analysis of bulletproof jacket. So again, whenever you are going for any kind of failure or destructive testing, you can also check what kind of failure, what type of fracture happened after the impact, or any kind of tensile testing. So according to that you can modify your resin, you can choose your resin materials as per your requirement. So these are the details, or this work is already published in these two papers, so you can refer, or you can go through from these papers, and you will be understand exactly what we have done. Then disentangle polyethylene. Now I am coming to the gel spinning fibers, and that high performance laminates widely used for the armor application. All bulletproof vehicles, bulletproof jackets, all are nowadays manufactured from this gel spinning process, gel spun fibers. And I already told this is the imported materials. This is the imported materials. We are not manufacturing. All you heard na different vehicles which provide the protection against the bullet. In that case, either they are using the bulletproof glass or bulletproof gel spinning process. So in that case you can see first you are using a UHMLP polymer, then you need to make the fiber. So that is not a fiber, basically I will say filament, because fiber terminology generally used for the small quantity entities of the materials, and the filament in that case is the continuous fibers. Then you need to prepare the ply precursor. This is the precursor materials, and from this bunch of the filament you can say yarn that is passing through the resin, and from after that it will go through the drying, and then you are making the ply, and you can say this is the precursor materials. And you are using here whatever you are using the resin, that is the thermoplastic in nature, and generally PU based, polyurethane based thermoplastic polymer is used in as a resin applications. Then from this precursor you can also change the orientation. So maybe in the last 2-3 classes, ply, different cross ply or 090 or different type of lamina and laminates things discussed. So this is the, you can say this is the lamina, and then you have prepared the laminates as per the directional, like 090, 045 as per the requirement and where you are getting the better result. So generally it is reported 045 and 045 something, that is giving a better performance. But for the product, generally as a researcher we can prove that this kind of configuration is giving a better configuration, better performance, applications. But the concern is that whenever you are going in the like a shop floor, then that whatever you have prepared the combination, that should be also feasible. Suppose that you are using a different orientation, in that case waste is also more. So sometimes if you are improving like 2 to 3%, 5%, 10%, that is not the significant for the industry point of view. So in that case you will see what will be the easy process which can be useful for the applications. So these things bother during the, like whenever you are working in the industry. As a researcher you will not bother. You will say, okay, fine, I am getting good result in this, then fine. So as a researcher I would say we are happy with it, but we are not concerning about the manufacturing process. So whatever you are designing the composite or the process, that should be feasible at the industry point of view. That is also we should keep in mind. So generally it is arrangement in the 0 and 90 direction. 0 and 90 in the all product we will get in the this kind of form. All are imported product, and 090 kind of around 48 or 30 layers is used, or 50 layers, and that is depend on the threat levels. I told initially, suppose that in case of the bulletproof vehicles, that we need to provide the protection against the snipers, and maybe the more than that, like barrels, different type of barrels, different like 30 mm, 70 mm, different type of ammunition is there. So in that case the number of layers will increase. We need to increase the number of layers, and again that will be increase the weight. So same protection we will not provide the personnel, that we can increase the weight in case of the vehicle, because we have a not problem in that case to increasing the weight. So initially I discussed that we have prepared the polymer from powder to the direct tape, and this gel spinning process, the imported material that is manufactured from the solvent or gel spinning, in that case you have to use the solvent, and this process is the solvent free. Basically it's like a melt spinning process, but not exactly melt. Maybe you are from mechanical sintering, so it's like a sintering process, just fusing the polymer powder, and then you are making the tape, and then further you are going for the drawing or stitching, and you are getting the high modulus, high strength tape. Then after making the tape you can go for this directly from this ply precursor manufacture, then you can prepare the different laminates. So this is the cost effective process as compared to an environment friendly, because you are not using solvent, but in case of the gel preparation you need to use the solvent. So this way this method is the beneficial, but the limited applications of this material is that you can use for the armor or this kind of application, where for the composite application, because this UHMWP fiber is also used in case of the lighter weight bag, like trolley bags. Now you heard about the lighted solutions and sports bag, that is also manufacturing from this materials, because the density of the UHMWP is 0.97, and this fiber is 15 times stronger than the SS stainless steel. Then this is the materials, and we have done the characterizations and prepared the different structures form. We have also prepared the from that tape, the continuous tape, we have prepared the yarn and then fabric, and from that fabric as well as the tape we have prepared the different type of laminates, cross ply laminates, as well as laminates that is based on the woven preforms. So from this manual techniques we have prepared from the tape this laminates, and this is the scanning electronic microscope key, how the delamination happen, what will be the process temperature, process parameters during the laminates formation. And we have also conducted the tensile dynamic impact behavior of the materials and optimize the temperature, pressures and structures, effect of the fabric structures, and finally we have prepared the panels from these materials. So these are the failure analysis after the tensile as well as the impact. So this is the low velocity impact, and then we have prepared the soft armor panels, and these soft armor panels we have tested against the 9 mm bullet, and we got the successfully impact resistance properties from these materials, and that is equivalent to the indigenous, that is equivalent to the imported item which is supplied by the DSM Dynama and Spectra. And here you can see the impression. This impression is very less after the bullet impact. This is the real time bullet testing, and we have interesting result find that whenever we have converted this LDP, that disentangled tape, in the woven structures, the structures in the same weight is failed. But whenever we have prepared that cross ply laminates composite and followed by the 090 pattern, and the same material, same aerial density, you can say weight of that panel, we are able to stop the bullet. So only what we have changed, we have not changed the materials, we have not changed the processing temperature, only we have changed the structures form. Only here we have changed the structures form, and we are getting the positive results. So while the composite formations, each and every step is important, structures form, preforms, preparations, everything is important. You need to take care while designing the any composites for your desired applications, whatever you are planning the applications. These are the failure modes after the destructive testings, and so the detailed study you can go through these papers. And thank you everyone for listening patiently. So any doubts and queries? So I think I have covered different segments, so it's very difficult to correlate, but definitely it will be helpful for your research. I hope या तो आपको सब कुछ समझ में आ गया या फिर कुछ नहीं है. Fine, thank you.
इम्प्रेग्नेट कर रहे हैं फाइबर को, जो हम इम्प्रेग्नेटेड फाइबर हम 3D प्रिंटिंग में भी यूज करते हैं.
फोम मिंगलिंग करके definitely you can use. Even though you can first start with the braiding or friction that is available in our department, so you can start. You are from NIT, na? No.
From IT, but he's asking because you have
You can use because matrix in that case maybe your matrix is melting. You can definitely use in case of the 3D printing that filament. Thermoset basically when you want to use in the 3D printing. So how I don't know it will cure, and after that how will it will again melt, because thermoset filament already cured. Then again it will not melt during the printing. Thermoset in the resin form. In case of 3D printing.
not in the filament form. You want to use
No, he want to, I think, thermoset resin in foam. With the impregnation, yeah. But then in case of the foaming, you can pass just the thermoset resin from the resin, and then you can use. So that will in that foaming you will not able to, because of filament yarn of thermoset resin, na? You will not get. PLA filament you can use, but thermoset resin filament you will not get. Only you can get the resin, and resin in case of the commingling you need a filament foam. Two filament you are merging, and the matrix is also in the filament form, but in case of your case the matrix is not in the filament form, na? You just want to impregnate. From that you can use the impregnation technique. Why you will go for the commingling?
After impregnating, can a single filament be
After
curing the resin, after impregnating,
you can make the filament.
Yeah.
You can mingle. Then again you will go for the 3D printing, so your filament will melt. Thermoset will not melt. That is already set, na? So then there is no use.
but currently we are already using a fiber filament that is already
Thermoplastic in nature.
That has been impregnated with the thermoset polymer.
Yeah. Then we are coating a thermoplastic material on that fiber.
You are using carbon or glass?
Yeah.
Carbon that is already coated with some thermoplastic. Thermoset resin. That is resin, but in commingling that will be not useful. Yeah, you can use with the thermoplastic resin in case of the commingling. But again, in case of the there is a limitation of the commingling. Some fibers that is brittle in nature, again you will get a problem. Like carbon or glass, it's very difficult because the commingling is done by the air. So during air, and that air followed at some 45 degrees something, so it will crack, it will fracture the fibers during the commingling process. That may create the defect. Any other? Polymer bags.
Harmful for the nature. One I have agreed on that. But when you are
I think polymer
working
bags-
on composite materials, that is not harmful for the nature.
No. Polymer bags is not harmful. At a particular thickness of that polymer film is harmful. Otherwise, polymer, if you are properly recycling, then you can recycle. I think 0.3 micrometer something. Less than that sheet is harmful. So nowadays you are also seeing that thicker sheet is also, thicker polyethylene bag is also used. Recycle. Plastic, yeah, this is that like debate. So whenever the plastic manufacturing industry, they will say we are recycling these materials, recycling 2-3 times, then it's sustainable. And if you are go for the natural kind of product, then they are claiming ki it's using water resources. This way they are saying ki this is not a recycling. Both way they can prove is the recycle. Actually, I would like to say ki as a sustainable is nothing as per the requirement. If we are talking about the 16 SDGs, Sustainable Development Goal, and the Ukraine or this kind of war is happening, then where is our sustainability? Right? So for our country, you can say protection or that perspective, we will not bother about that first. We should bother about our protection part. Suppose that they are selling and they will go for the they are after 10 or 15 years they will say we have developed this sustainable materials for the bulletproof application. By the way, that time we are able to manufacturing these materials. All man-made fiber are not sustainable if you are talking about that. The way of living of the last like 10,000 before years ago, that is the more sustainable. We are from 50, if you say from the 50 years back, we are more sustainable. Nowadays we are not sustainable. If you talk about the sustainable point of view, so we can say we are recycling 2 or 3 times, then we can increase our earth life, maybe 100 years or 200 years. In that point of view, we can say we are sustainable. But exactly if we are following the old culture, that will be the more sustainable. It is the old relative term.
Focus our research in metals.
Yeah.
What is your opinion on that?
Okay. But again, in case of the metal, like rusting or those kind of happening, nature, yeah.
Still, if you are using natural fibers,
Like natural fibers, you can't use with the metals, na? Natural fibers, all natural fibers you can't with the metals.
still your matrix material is a plastic.
Yeah, in case of plastic, but
What is the point to raise this? Natural fibers.
Sir, I would like to answer. If you are using a metal part,
We'll discuss later.
yeah, you are right. Metal is also, sometimes I am also thinking why we are replacing bulletproof jacket with the metal, but again weight is the concern. So specific product we can use this kind of materials, but yeah. But people are also working in that direction. It's not like in case of the metal, they are also using like a patka. In case of the head protection, that is also made from the metals. For the level 6 or more than level 6 or 8, they are also manufacturing in that direction. But if you talk about the impact performance and the strength, the metal, there is I think no metal which is meeting the standard of these polymeric materials. So for this specific application, I would like to say that this polymeric material is important. If you are able to achieve in case of the metal those kind of performance and properties, then that will be the very good solution. But there is a limitation in case of the metals. So I think about the metals, you know, from the mechanical background, you know well what are the limitations, because that is not my area, so I will not able to say comment on that. But yeah, initially this bulletproof jacket was made from the metallic metallic panels. But that metallic panels are around 50 kg, aerial density is 50 kg, and from that polymeric materials it is reduced up to the 2.2 or 2.3 kg panels. But if you talk about the aerial density, that is around 15 to 16 kg per meter square. So that much the reduction. So that may be the one reason, the weight reduction. And yeah, if you are saying ki in the metals, if you are thinking ki that kind of properties if you are able to get, then definitely that may be the solutions. Because I have seen some metals too heavy, but they are heavy as well as the aerial density is large. Whenever the bullet impact, all perforated. So weight is the main concern in case of the personal protection. Definitely again in the vehicles, now why people are shifting to the their composite based vehicles. Again, fuel, they want to save the fuel. They are saying ki energy, we are saving indirectly the energy and those things, and then by weight. Then they claiming that if you analyze the life cycles of the metals as well as entire this polymeric materials, then they are claiming that energy saving or resources saving in case of the polymeric materials. So all over that is the game. In the small, like you are thinking कि एक दिन के लिए सोचोगे या मतलब 30 days की लाइफ साइकिल के बारे में सोचो तो मैं भी आप बोलो कि मेटल ही अच्छा है, बट उसका इंटायर लाइफ साइकिल सोचोगे तो maybe the polymeric materials, why that's why they are shifting toward this polymeric or fiber based reinforced composites. So I think you got my answer somewhere, right? Okay, any doubt? So thank you.
thankful to you for your valuable time. And you have nicely, I think, connected the participant with the thermoplastic manufacturing and characterization. I have seen some of the participants have interacted with you on the thermoplastic and metal use, okay, which one is recyclable,